Thanks, Jordan. Thank you, everyone, for powering through the midday mark and staying with us here. So definitely appreciate your time here. Like Jordan said, I'm Brian Wong. I'm a product manager on the connectivity team. I've been with SailPoint for about a year now. Prior to this, I was actually another product manager on an API platform for an event management company. So I'll hand it over. Feng Ming, do you want to introduce yourself?
Sure. Hi, everyone. My name is Feng Ming. I'm a software engineer here at SailPoint. I've been with the company for 4.5 years. So both Brian and myself are from the team here at SailPoint that built this SaaS connectivity platform.
Yep.
That's pretty much about myself.
Thanks, Feng Ming. So Feng Ming, and I will go through a couple of things today, but as Jordan mentioned, just the big announcement that we're releasing this today. It actually went out into beta early or mid last year, but Feng Ming will touch on the just a high-level walkthrough of all the pieces of what we're releasing today, and then Phil will go into a bit of a deeper dive and an actual build out on that connector. So stay tuned for that. It's right after this session. And then Fernando will actually go into what he sees out in the field, building out actual connectors, maybe the pros and cons of different tools out there, as well as some of the limitations that you might see with this framework. So it's built up, but we are still building on it, and we'll talk about it. So the main problem I think we want to discuss is that I think it's no surprise that SaaS vendors out there, the proliferation of all the different tools that are available, it's just exploding. I think our customer base is pretty broad, and their usage of those tools is equally growing. So it's just almost an effectively unlimited or infinite number of connectors that you potentially need to get source coverage for. So I think SailPoint has a pretty good list of connector offerings out of the box, but it's a finite list. And so what we wanted to do today is arm you with the tools, additional tools to help you gain coverage for the additional for all the different possible sources that are out there. The second problem I think I see is that I think Colin, touched on this in his presentation yesterday. He talked about, almost reverse engineering some of the communications that he saw with Box, and kind of digging into how these vendors actually implement their interfaces, whether they're APIs or SDKs. Sometimes you don't always have a clean, RESTful design. It's really up to the vendors to build it out. It's up to their discipline and their maturity to build out intuitive APIs. And some standard is out there, but it's not a guarantee that they follow it. Even Skim, for example, that's a pretty standard protocol, but there are some deviations to how that's implemented. So the variability of all the different SaaS sources out there is a challenge that we've tried to address with this new release. So in 2017, we actually launched a framework called Open Connector. It was based off of Java, but it is a VA-based framework. It was pretty high learning curve. You needed to know a fairly complex connector contract to implement things, and in fact, a lot of connectors that were built on that framework required some level of services engagement. So it was fairly heavy in building out connectors using that framework. Between then and now, some people might be more familiar with the web services connector. That is, that's still an option. It's seen much more adoption. But if you're looking for that low code tool, that's the tool for you. But today we wanted to just add another to the toolbox so that you can choose the right tool for the right job. So SaaS connectivity, it's a much lower learning curve, and that's demonstrated by, since we went beta mid last year, we've had pretty rapid development. Our teams kind of drank our own champagne and built out over 18 new connectors on this framework out of the box use for our customers. So it's a pretty rapid clip. The second thing about this is with TypeScript and Node.js backing this, we are leveraging not just SailPoint's community. We have a great developer advocates in our communities out there, but we also have the support of even the general public community around there. Any packages for, you can import any other packages that you need to manipulate data or to go grab data. Things like that can be pulled into this framework, and you can use that to implement in your connectors. Maybe even the source system has their own SDK. You can pull that in, and you don't even have to look at their actual API calls and reverse engineer it. It's all abstracted away for you. So that's also a great benefit of this framework. The last thing I think is a pretty fundamental shift in how we view connectivity. And that is what has allowed us to unlock some of the benefits. And I'll talk about that in the next couple of slides and into the roadmap here. But in short, this framework, it operates entirely in the cloud. Doesn't require a VA. And there's definitely some benefits that we can gain out of that. So let's take a look under the hood real quick here. So I think this is pretty standard. You have your VA in your own infrastructure. You might have a direct connections. There's on-premise systems like Active Directory and a database that is flowing through the VA and then onto IdentityNow cloud. Well, what happens if you add or you need a SaaS source integrated and connected so that you can grab identities from? Well, one example is the Workday connector right now is actually, even though it's a SaaS vendor out there, the data flows through the VA and then hops over to IdentityNow. It's processed through the VA. The interactions are orchestrated there. The logging, just the operations run through the VA and then onto IdentityNow. So with SaaS connectivity, that's all, the middle piece that you saw on the previous slide, that's all gone now. So there's direct connections. There's what we're internally calling the connectivity 2.0. That's our internal denomination, but essentially it's a container for connectors to run within an isolated runtime that has a direct connection out to SaaS sources like GitHub or Smartsheet. So there's all sorts of benefits to that. There's one less hop to go through. There's not a VA in between, less latency. But there's also, now that it's closer to SailPoint's infrastructure, we have access to do certain things like improve upon things like observability. We can scale up and down a little bit easier. But with that said, not all of it's built out. So let's get into what is remaining here, and so that we can realize all the benefits of being in the cloud. So the roadmap here for Q1, we're probably getting close to finishing up this Delta aggregations. This is just if the source system has the ability to send us deltas, we can take that in and improve upon the performance of aggregations. So that's coming soon. Cardless is a UI improvement. If you needed to configure your connectors to support some type of cardless, that is something that you can do. Change password operations now supported. And then, as I mentioned before, we're using our own framework to roll out some of the out-of-the-box connectors, like Skim is now running in the SaaS world, or the SaaS framework. In Q2, we're looking to operate the web service connector on the same framework. So it doesn't require a VA. In Q3, this is one big thing that we're looking at enhancing or improving in the future. This is, the difficulty of accessing logs is the problem that we're trying to solve here. Is you see that not just with the VAs, connectors running on the VAs, but you also, we've also improved on that with the SaaS connectors. You can get logging, and Feng Ming will talk about that, and Philip will kind of walk through how you get logs from the cloud now. But we wanted to come up with some unified or better way to get information, operational information like logs out of the VA or out of our cloud, so that you can see what's happening at the connector level, at the VA level, so that you can do troubleshooting, you can monitor things, and do your own self-help there. And then going beyond into the future, we're looking at supporting on-prem systems with the same framework. We realize that despite there's a lot of growth in SaaS connectors out there, or SaaS vendors, there's also a large portion of sources that are within your own walls that you also want to get connectivity for. And we want to be able to allow you to use this easy, developer-friendly framework to build that out. The next thing is if the source system has the ability to send updates asynchronously, we want to be able to ingest those into our SaaS platform and do support things like webhooks. And lastly, automatic schema handling is if, as I mentioned before, sometimes the target systems don't always announce or follow standards of adding, deprecating or updating endpoints with new fields. We want to be able to add some flexibility in there so that the connectors are more resilient and they can almost detect that there's a new field in there without deploying a new connector out there. So this is not set in stone. I'd definitely love to hear your feedback to help me shape the roadmap, but let us know in the Discord chat. And with that, let's get into a demo. Feng Ming?
All right. Hopefully everybody can see my screen. Okay, I think that's check. All right. So during my section, I'm going to show you around the SaaS connectivity platform, show you how it works, how to interact with it, and how easy it is to build a connector. To start with, let me show you the toolings we created for this new platform. So firstly, we have a CLI, a command line interface that helps you initiate a connector project locally, helps you create a connector entry from our platform so that you can see it, use it right from your IDN tenant. Can also help you upload your connector project to your IDN tenant, manages versions, view logs, and a lot more. So the CLI is public available under our GitHub organization under this repo called SailPoint-CLI. And of course, it's currently pre-production mode, so there could be some changes. So from this README file, right, it basically covers all the installation or some basic use case of that. To start with, right, let's talk about installation, how you install CLI to your local machine. So the CLI can really be installed on all operating system, like Mac, Windows, or Linux. For Mac, is available from Homebrew. So just run this command and it will be installed. For Mac and Linux, you can manually install that by downloading all the code from this repo, right? It's publicly available to you. And then run this make install command. If you want to do it this way, you do need Go to be installed before installing CLI. Moving on for Windows, from the release section of this GitHub repo, we do build Windows executables, those .exe files, so it's available there. So you can download those executables from there and set it up if you're using Windows. Moving on, the next big section is the configuration. So the configuration process is mostly for you to tell CLI the credentials and the credentials for your IDN tenant and where it is, right? The URL for it. So this is for our CLI to be able to authenticate into your tenant and then talk to our APIs. So there are a couple of ways to configure that. So you can run this sail config command where it will walk you through entering this personal access token. So we do have these cool GIF demo show you how to work around with it. You can also manually configure that by adding those credentials into a config.yaml file and place it in the specific location that is needed. And you can also we can also read those stuff from environment variables if you prefer to do it that way. Yep, so that's pretty much everything about our CLI. So moving on, we have a SDK. So basically, it's a framework for writing SaaS connectors. It provides all the classes, interfaces, helper methods, all the plumbing, etc., for you to quickly stand up a working connector. So the SDK is also publicly available on GitHub under this repo. And it is written in TypeScript, as you can see here. It's also just suggesting that connector need to also be done in JavaScript today. In future, we could extend that to other languages. So the SDK project also has a lot of a comprehensive README. So it walk you through the setup process, how you install that if you want to import that into your project. It gives you some example code about how to start handling those commands that IDN would send to you. But don't worry too much about this. During the demo, I'll show you how to get things bootstrapped from our CLI so that you don't have to go through these steps. And for example, here we also have these logging logger provided from the SDK so that the logs can then be easily accessible from our CLI. So another big part, another tool provided as part of provided from the SDK is this SPCS process. So this process is here to help you run your connector locally. So when we build the SaaS connector, we always we keep in mind that trying to make your local dev work more. We're trying to like make sure that you can easily debug your connectors locally, all that kind of stuff. So this SPCX process, what it does is when you run it, it will start a HTTP server locally. By default, it's on 3000 port. You can override that. So this HTTP server is then running your connector code, all you have locally. And then you can send a post request to that endpoint like this and giving the payload. The payload is basically the command that you're trying to test locally. And then your connector will then pick that up and then execute a code that you have. So with this process, it will be very easy for you to see what's going on locally, to debug, to set up breakpoints, use any debugger that you want. And we hope it will make your life easier when you are building a connector locally. All right, so that's pretty much about our SDK. And just a bonus, so we 6 days ago, we published our SDK to NPM, and it's now on its first version 1.0.0, so it is publicly available now. All right, so now let me walk you through the process of creating a connector. All right, so from my local machine, I have CLI installed and also configured and pointing to my IDN tenant. So the very first thing that you can do is to use our to use our CLI to init a connector project. By the way, all the document of the CLI about how to use that is also available from our GitHub repo right here for connectors. We do share our CLI with transforms, but connector is one of the major part of that. Let me bring up my Finder. Okay, so from my terminal, right, I am at desktop. So the CLI command to create a connector project, right, locally can be done by cell con init. Let's call it demo connector. All right. So now you see this demo connector folder is created. That's the connector project. And we also print out the file structure here. So if you're familiar with Node, the very first thing that we have a Node project, right, when we have it is to actually install all the JavaScript dependencies. So to do that, let me navigate into my connector project and run an npm install. Right, while that is running, let me open up my connector project from Visual Studio. You can use any IDE that you like. And let me walk you through the file structure of the connector. So let's start with the package.json. So this is the required file for a Node project. So we have the project name, the version. So from the Node script section, we already pre-populate all those helpful scripts so that it would help you through the local dev process. I'll get to them later. So moving down, we have this dependency section, and as you can see, is referring to our connector SDK. And we also have some other dev dependencies like Jest for unit testing. We have TypeScript. We use this cross-env plugin so that it better runs on all environments like Windows. Right, that's pretty much about that. Moving on, we have this connector spec.json. So this basically tells IDN what it should show up from the source page. So if you ever create a source before, you know, from IDN UI, you'll see a lot of things like source config, like account attributes, some like account create template, etc. Those are all described here. So from and by the way, the specs short for specification, if you're curious. So from here, let's go through them one by one. So the name field. So this is the name that this connector will show up in IDN. Basically, when you're creating a source, you are viewing the list of available connectors. This is how they will look like on IDN. So down here, we have a list of supported commands. So for this default project, right, initiated by CLI, it supports test connection. For example, like that's what's running when you click on the test connection button from IDN. We have account list, which maps to account aggregation. We have account read, which maps to the refresh, the attribute refresh feature from IDN UI. And basically, we also have like other commands available. We do have a full document on our developer portal showing you exactly what can be done by this spec file, all the available commands, all the configurable fields, etc. But this is just a very basic minimum example for you to quickly get started on a connector. So moving down, we have this source config section. So from here, we have one menu called configuration. Down there, we have one section There are some section, title, and help message. Those will all show up from the source config section when you are creating a source for this connector. And by default, this connector has one source config field. The label that will show up on IDE is going to be token. The type for this text field is just going to be text. It could also be something like password, stuff like that, right? Like radio buttons, drop down list, stuff like that. And basically, so normally the stuff that you potentially put in here will be the credentials, right? Username and password for the source system that you are trying to talk to, etc. And when you set everything up here for the source config section, whoever is creating a source on UI will be putting in their unique credentials so that you can use them to talk to the source system. Moving on, we have account schema. So this basically, this will show up from the account schema tab from the source page. This basically tells us how your account would look like. For example, as it's written now, we are saying that each account that is returned from this connector should have a first name, a last name, and an email, and their corresponding types and short description, etc. And last, we have this empty entitlement schemas. Because we're just working on this default project, right? We don't even have the entitlement-related commands enabled here, so that's why it's empty. But once you start building your actual connectors, right? I'm sure you're gonna add new stuff in that section. It's gonna look similar like this, basically telling us how your entitlement would look like. All right, so this is pretty much everything we have for this default connector spec file. That's basically all the non-coding portion of connectors telling us how the source UI should look like. Moving on, let me show you the code that makes this connector happen. So under this source folder, we have this index.ts file. So that's where we'll look where the connector process started. So here we are importing all the classes, helper method, etc. from the SDK. When the connector process starts, the very first thing it does is to read configuration. So this configuration will just be a free-form JSON containing all the credentials, the source configs that a source owner saves. So that should look exactly the same as what you are setting here in the spec file. So after it has this config, it then passes that into a client. The reason we organize our code this way is that this index file is just having all the handlers for all the different commands. And then we pass off the actual code to talk to the source system into this my client. You can rename it whatever you like. That's right here that I'm gonna get to later. And down here, we have all the command handlers. So for example, for this default connector project, right? We need to support test connection, account list, account read. For each of these handlers, the function signature tells you exactly how the input should look like and what we are expecting you to return as output. For example, if I mouse over this test connection output, we are expecting you to return this empty JSON if it's successful. And you can also see these account list output, the account read output. And for example, for account read, there is an input, and that would be this identity field. All right, let's look into my client next. So for example, let's look into this test connection handler. So from this my client.ts file, for example, this test connection code is currently just returning this empty JSON. So this means that if I would run this connector as is, it would always success, right? The test connection will always work. But I'll show you how to change that and how how the code could be around that. So let's start from the top, actually. So the default connector project is just having two fake accounts in memory, right? So when the client is constructed, this source config is passed in. And here we are doing a validation. We're saying this token has to be provided. Otherwise, we will throw a connector error. So this is how you would communicate with IDN if something goes wrong for any of those commands. For example, you are trying to do a test connection and the credential provided are not working. What you can do is to throw a connector error saying that, for example, your credential is bad, right? So let's quickly do that for our test connection. So what I can do is say if it's the token is not equal to developer day, then I will throw a new connector error saying token must be developer day. Although I'm giving out this token, but let's just do it that way. So what I'm doing here is that this token has to be developer day, right? Otherwise, I'll just throw an error and tell you what we're expecting. We do have these two methods being called for account list, for example, where we are just returning those two fake accounts. We have this account read, where we are also reading from those fake accounts. Yeah, that's pretty much about it. The next step, I will show you how to run your connector locally. You must be, I'll show you how easy it is to run it locally and how you can debug your connector locally, how to use that SPCX process that I just mentioned about. So heading back to package.json, you will see that we have this dev script populated here, and it is running this SPCX process. So basically, all I need to do is to run that task by npm run dev, by calling that. Once that process started, we have this process running here. And now I will be able to call my local handler, for example, this connection using something like Postman. So from this Postman window, I am sending a post request to localhost 3000. I am sending this payload where its type is just test connection. So if I send that, I got a 500 status back, and I got this error saying from my client line 34, it says token must be provided. So this is also how easy it is that to debug your connector locally, to run it locally, that we tell you exactly where it goes wrong. And so that you can fail earlier, right? Instead of having to upload your code to IDN and then test it there. You can do it, but just take longer iterations. So heading back to line 34, we see that it is during this init process, right? It's expecting a token to be provided. So in order to provide configs to your connector process, all you need to do is to add a config key, and down there, we're expecting this token. Okay. If I send it again, you will see another error now coming from line 50, and it's saying the token has to be developer day. So that's exactly what we just wrote a moment ago. So lastly, if I change the token to developer day, if I send it again, and now I got 200 status back, and I got the expected output from here. So some other cool things this SPCS, this local dev process provides, right? For example, in this account, in this test connection handler, we log a message here. So if I want to, for example, if I find out that that I have some bug that I need to fix, right? Or I need to write some new code and test it again. So all you need is to fix, do whatever modification you want. For example, I would say from developer day demo. And as soon as I save this, this SPCS process will kind of have this file watching thing where when it detects the file change, it will compile again. If I save, you see it's compiling. And if I send it again, I will see the updated message here. And of course, if you made some typo and save it, it will tell you there are errors and it tells you where it happens. So yeah, we hope hopefully this will help you speed up the connector dev process locally. All right, and lastly, let me show you how to debug it, right? So you can, of course, use any JavaScript debugger of your choice. So I've been using this Visual Studio debug terminal. And sometimes it's not that compatible with this cross-env plugin that works on Windows. So let me just quickly get rid of that. So now my dev task is just calling SBCX. So from this JavaScript debug terminal, if I do npm run dev again, this orange color tells me that the debugger is running. And if I, for example, set a breakpoint here for this test connection method, if I send it again, it will hit my debugger, and my Postman is like waiting. I can step over, I can continue for this to pass. So basically, for all the tools that we provide, the CLI, the SDK, we really hope that it will speed up your local dev process and save a lot of time and have fun creating those connectors. All right, so now back to the big moment where I will show you how to upload your connector to our tenant and see it working kind of in real life. So first thing that you need to do is to build and package your connector into a zip file. So we already have that script for you. So it's called packzip. So all I need to do is to run npm run packzip. When that's running, it will create this dist folder, short for distribution. And once it's done, we'll have this zip file, demo connector zip file. So now, the next thing you want to do is to create a connector entry in your IDN tenant. So the command to do that is sil con 8, and let's call it demo connector. Now you have a connector entry created in your org. The next thing to do is to upload this zip file that we just built. The command to do that is sil con upload. So from here, we need to provide the connector, which is the -c under the -c flag. Here you can provide either the alias or the ID. I'm using alias here. And you also need to provide the location of your connector zip file. That's under the -f flag. That's under the dist folder, and then demo connector zip file. And now we just successfully upload our connector to IDN. And after this, right, let's say you found some bug or added some new feature and you want to update your connector from IDN. All you need to do is to make your code changes, run the build process, run this packzip script again, and then run upload again. For example, if I would just upload the same zip file again, it will tell me now the version is on number 2. And lastly, we should be able to see this connector from the IDN tenant that is talking to and create a source on that. So if I do create new, I should see my demo connector. It's right here. I can create the source on that. Here we go. And just recall from the only piece of code that we added right on top of this default connector. If I just give it a random token and save and try to test connection, it will give me this exact error that I wrote when I'm throwing that error saying token must be developer day. If I copy that, if I set my token to be developer day, and if I test connection again, it will be successful. And now you can do all the other things. For example, this this default connector has like the two accounts, the two mock accounts in memory, right? You can, for example, run aggregation, and it could take some time, but eventually you should see two accounts getting aggregated. And yep, there we go. We have two accounts aggregated. Yeah, basically that's how you can create connector locally using our tools, using CLI, how you would interact with SDK, how you would build package or connector locally and upload to IDN to your IDN tenant, and then interact with it from the IDN UI. So my session is just a quick intro to how those tool works, how the basic stuff will work together to make this happen. My colleague Philip will have the next hour after this session that he would dive deep into building a working connector, talking to an actual source system, and have it all working. Yeah, that's all we have. All right, we have 2 minutes left. Maybe we can answer some questions from Discord. So we do have one question asking, with the new WS 2.0 connector, will we be able to use rules? Will they become cloud rules, or will the rule runner be confined to the connector runtime? There are currently not that much planned on that, but if we do plan to do it, it will show up on our roadmap. Yep. Yep, I think that's all we have. Thanks for your time.